Hello, hope everybody's doing well. This is just an explanation of Lab 3A, kind of what you need to do. Now, you could complete the lab by just following the directions found here. Also, there's a video to watch so you know what's going on with the actual simulation with this data. Now, this is just basically sample data. So we've collected the data for you, and thus using this data, you're going to finish the lab, even though you did not actually do the lab physically yourself. So I'm going to click on the video, just kind of giving you a brief explanation of what's going down in this video or in this lab. And we did this lab a little bit before we left. We didn't finish it. So we have our target, we have our rolling car, we have our target car. We're going to put different masses in each of the cars. This is how we're going to kind of measure the effects of momentum on cars. We're going to pull back the rolling car and we're going to shoot it at the target car. At that point, the rolling car is going to pass through this photo gate. That's going to give you the time through photo gate A, which essentially is your time for the rolling car before the collision. Then they're going to collide. So one of two things are going to happen. This car is going to hit this car and propel the blue car forward, and the orange car is going to stop instantaneously. Or the orange car is going to hit the blue car is going to get shot forward, and the orange car is going to continue to move forward and pass through photo gate B. So what we know is we can measure the speed of the car. When we're measuring the speed of the car through a single photo gate, we're going to use 0.01 meters. That's the distance for this little thing sticking up on the car. Then we're going to use the time right here. So this is the time. So here's my rolling car before the collision. Thus, this is the rolling car when it passed through this photo gate. So what you're going to do here is you're going to take 0.01 and divide it by this number right here, 0.0188. And then I'll get my speed. Then I'm going to do the same thing here, 0.01 divided by this, 0.01 divided by this, and so on down. Then I'm going to come over here and I'm going to do the same thing, 0.01 divided by this, 0.01 divided by this, and down, and the same thing for this column. That is how I would calculate and finish off this data table. And essentially what we're doing is calculating the speed of the rolling car before collision, speed of the rolling car after collision, and the speed of the target car after collision. From there now, you'll use data table 1 to fill out data table 2. Now, data table 2 is calculating momentum. So we have the rolling car before collision. Now, the thing we have to understand is that the target car was not moving before the collision, thus its momentum is automatically 0. So the only thing I need before collision is the momentum of the rolling car. Now, in order to do that, okay, I'm going to take the mass of the rolling car times that by the speed of the rolling car before collision. Thus, when I do that, I'm going to take the mass of the rolling car right here and times it by the speed of the rolling car right here. And that's the number that's going to go right here in this box. Then I'm going to do the same thing for trial 2. Mass of the rolling car times the speed of the rolling car, and that's going to go right here. Mass of the rolling car times the speed of the rolling car, and that will go right here, and then so on all the way down. Now, momentum after the collision, now we have to understand is that in a couple of these situations, both cars moved. So because both cars moved, or were moving, because of that, we have to calculate both the momentum of the rolling car and the momentum of the target car and add them together. So start here with the rolling car. You're going to take the mass of the rolling car times the speed of the rolling car, get a number. Then you'll take the mass of the target car times it by the speed of the target car, get a number, add those two numbers together, and then that is what's going to go right here. Do the same thing for this trial. Mass of the rolling car times the speed of the rolling car, get a number. Mass of the target car times the speed of the target car, get a number. place that right here. Then continue to do that all the way down for both of these. Okay, calculating the momentums of the rolling car after collision and the momentum of the target car after collision, and then calculating the total momentum by adding both those momentums together. If you have any questions on this, I will have office hours 1 to 3. Please log in and see me. Otherwise, set up a virtual appointment, send me an email. Any of those would work. Thank you and have a great day.